still haven't gotten all the emails from the groups. People's grades are going down by 10 points every day as I send the email. I printed out a couple people's I printed out a couple people's surveys that they asked me to, so I'll go ahead and pass those out at the end of class. Whatever was asked for me to print, I went ahead and print that. If you need your survey emailed to students at different schools, you need to send me an email about that so I know which schools you'd like me to send it to. Remember, next Tuesday's the big presentation. Mark DeBella, Kari Thomas, Newcomer, Castillo, they're all coming. All right, so let's jump right in though with the material. So what we do today is really going to get into the real statistics. And I want to start with what's called the normal. You're going to want to take some notes here, the normal model. By the way, I'll talk more about the common assessment later this week once I have all the data. Move that up. Hey guys, what's going on? You need what? I apologize, we don't have any.
I'm sitting there. Just over here.
You want to run to the restroom, Giselle, and take care of that, or? Okay. We need to be focused here. All right. So the normal model. I'll talk more about the CAs later this week, but performance was all right. We beat the other campuses, so good job on that. But we still have room to grow. We still got to get better. Right now, not everybody in this class is at the point where they're going to save money in college. Probably about 70% of us are above a 3. You need to get 100%. Anyways, let's move on to the left for right now. Normal model. This is what really is going to take us through the next several weeks of class. So the normal model is the following. So you may have seen some data like this in the past. We call this a bell curve. We call this a bell curve. And this is the most common type of distribution. So this is a very common distribution of data. So, for example, if we looked at, if we looked at maybe, right, like you could pick SAT, right? And if you look at people's SAT scores, many of them will fall in this area, right? A lot of people score in this middle area. Some people score super low, and some people score super high. The height of the bell indicates the frequency. So we have the height is indicative of frequency. So we have a lot of people clustered here, a few people here, so few, and then a lot of people like right in here, a lot. And with a normal model, we have a point. What's going on? We have this point here, and I'm sure many of you all read this weekend, called the median or the mean. In a normal model, the mean and median are the same. Why? The data is symmetric. If the data is symmetric, the mean and median are the same. So one important thing, the mean, the median, and the mode are the same. Mean, median, and mode are the same. Second important piece is that the normal model is symmetric around the mean. So, kind of what you have going on over here is basically what you have happening here. Now, oftentimes the data isn't perfectly symmetrical, but it's very close. Very close. Now, the next piece is that if you found the area, if you found this green area, all this area under the curve, the area under the curve equals 1. For calculus folks, they're talking about integrals here. So the area under the curve is equal to 1. Area under the curve is equal to 1. And I'll explain a little bit why that's important. All right. This next piece, yeah, Shamar?
The green part is all the area.
Yeah. It's like, so I try to like highlight all of it. Yeah. All right, now this is really the key. In a normal model, so maybe I'll redraw it here. Can we still see what's going on here? All right, so we have this kind of situation. And we have, this is the median and the mean, they're the same. And the rule with a normal model is that 68% of the data, or 68% of the observations, are within one standard deviation of the mean. So from here, which is mean minus one standard deviation, up to here, which is mean plus one standard deviation. Standard deviation is just a number. There is 68% of the data. So number 4 is 68% of the data, of the observations, of the people. 68% of the data is within one standard deviation, which is just a number. Remember, standard deviation is just a number, 5, 10, 15, of the mean. So this green, I'll highlight it in maroon. This maroon area right here, 68% of the data. And again, it may not be 68.000, it might be 67.985, or it might be 69.002. Point is, it's going to be basically 68%. If we extend this one more standard deviation, so maybe up to, let's call it here, which is mean plus 2 standard deviations, and extend this over to here, which is mean minus 2 standard deviations, we have 95% of the data. So what I'm going to shade in brown, 95% of the data. All right, so number 5, 95% of the data are within 2 standard deviations. Karina. Every normal distribution you ever see. Yeah. And then I won't draw this because the drawings get a little bit messy here, but within 3 standard deviations, we have 99% of the data. 99% of the data within 3 standard deviations. I should say of the mean. Mean, median are the same here, of course. So, why is it, yeah, Scripture?
Well, in the part where you have on the graph, what it does say, they'll post it like the mean plus 2 times standard deviation.
2, yeah. So, we often report scores as the following. So, on the Common Assessment for Algebra 2, you can go congratulate Mr. Kurth. Mr. Kurth's students scored 1 standard deviation above the district. So they were like way out here, doing really well. Other schools might have been 1 standard deviation below. And a lot of schools are right in here. Right? So for like AP Stats, we were over here. Another school was here, and one school was here. Right? So obviously, if you're way over here, it's really rare. Right? There's like not a lot of data is above the 3 standard deviations. Right? 99% is within it, so only 1% on each side total. So most of the data is within 3 standard deviations. So a lot of times when we say, like how well are people doing, we say they're half a standard deviation above the mean. So that means, no, they're about right here. 1 standard